Um, Consider being caught in the rain. Should you run or walk? Maybe you should run less time in the rain means less water falls down on you. Maybe you should walk. Moving slower causes you to run into fewer raindrops. This is a question you could try to answer with the scientific approach. So what is the goal of the scientific method? An organized plan for gathering, organizing, and communicating information is called the scientific method. You can use the scientific method to search for the answer to a question. The scientific method can vary from case to case depending on the question and how the researcher decides to look at the answer. So the question here is probably, how do I get less water on me? So you could run, but you might run into more water. You could walk slow. You don't really know until you have an organized effort to figure it out. So the goal of any scientific method is to solve a problem and to better understand an observed event. Here's an example of a scientific method. Each step uses specific skills, and the order of steps can vary. Sometimes you will use all the steps, and other times you will use some of them. So the first thing is you can make an observation, then you can ask a question, you could develop a hypothesis, you could test the hypothesis with an experiment, and then you could look at the data and determine if your question was answered, determine if the hypothesis is correct, and basically either your hypothesis is correct or it's not correct, and then you can go back and revise your hypothesis or continue it to make sure. You might test the running in the water one time, but it rains a lot. You probably would need to do it again and again and again to get an accurate observation. And then eventually, once you gather enough data, then you could develop a theory, and that's basically how the scientific method works. So making observations is a good place to start. You begin by just kind of observing things. And then forming a hypothesis is a proposed answer to a question. So the question at the beginning of this was, how do I avoid water? Which method is going to help me get less rain on me? And you can form a hypothesis just by watching people in the rain. You could test that hypothesis by manipulating the variable, have a bunch of people run, have a bunch of people not run. The responding variable changes in response to the manipulated variable. And then lastly, you're always going to have what we call a controlled experiment. And that's an experiment in which only one variable, the manipulated variable, is deliberately changed at time. So I would say probably the variable of walking speed versus rain. And you could control the rain. Maybe you make a rain device that just sprays water into the air that simulates rain. Drawing conclusions. A conclusion describes how facts apply to the hypothesis. So once you run all your tests, you might find an optimal speed for walking or whatever. Then you can develop a theory. A scientific theory is a well-tested explanation for a set of observations or experimental results. Once the hypothesis is supported in repeated experiments, scientists can develop a theory. So you got to collect all this stuff before you can come up with a theory. Now, sometimes scientists come up with kind of like a quasi-theory, and then they start testing it. But the theory part is based on lots of data. So question, how does speed affect how wet you get in the rain? Hypothesis, the faster your speed, the drier you will stay. Test it. Test whether the speed affects how wet you are when you get in the rain. In 1997, two meteorologists conducted a controlled experiment to determine if moving faster keeps you drier in the rain. One scientist walked 100 yards and the other ran in the same distance. The variables such as types of clothes were controlled. The clothes of the walking scientist accumulated 217 grams of water, and the clothes of the running scientist accumulated 130 grams of water. Draw a conclusion. The scientist concluded that running in the rain keeps you drier. So how does the scientific law differ from a theory? Well, after repeated observation, scientists may arrive at a scientific law. A law is a statement that summarizes a pattern found in nature. For example, Newton's law of gravity is a scientific law that has been verified over and over and over again. Scientists have yet to agree on a theory that explains how gravity works, but we know that there is a law. Scientific law describes an observed pattern in nature without attempting to explain it. What goes up must come down, basically. The explanation of such a pattern is provided by a scientific theory. A model is a representation of an object or an event. A street map is a model of a city. Scientific models make it easier to understand that might be too difficult to observe directly. Most models are based on math. So this computer model represents the interior of a plane and helps engineers visualize the layout of the plane. Models can help you visualize things that are too small to see, such as atoms, or things that are large, such as the solar system. An example of a mental rather than physical model might be comets are like giant snowballs primarily made of ice. As new data is collected, models can be changed and replaced by newer models. Safety plays an important role in science. Laboratory work may involve flames or hot plates or electricity or chemicals or hot liquids, sharp instruments, breakable glassware. Always follow your teacher's instructions and the textbook's directions carefully. Lab safety is an important thing. You never just want to dump chemicals down the drain because you don't know how they'll react once they're mixed together. Couple questions. What's a hypothesis? It's a proposed answer to a question. How does scientific law differ from a theory? A scientific law describes observations while a theory provides an explanation. What is the main purpose of a scientific model? C. To make complex concepts